Uh, Hello, students. Welcome in this session of IC engine. Okay. In the previous some session, we have discussed about the thermodynamics, some important concept of thermodynamics we have discussed, and some important questions which more probably come in this year. So that all the question I have discussed there. Now in this session, we will discuss about the what IC engine. Just wait. Okay. So first we have to understand first you have to understand that why how IC engine is going to actually works, and how combustion is going to take place, and what is auto cycle, what is diesel cycle. So these are the some basic points. So this thing I will discuss here. After that I will move to the some important questions that will I will discuss also today. So first try to understand how IC engine works. Okay, how IC engine works. What is the function? Why I used to say that auto cycle is a constant volume heat addition and constant volume heat rejection also. Why I used to say that diesel cycle is constant pressure heat addition and constant volume heat rejection. That all are you can feel here physically. And after that I will discuss the some important questions that more probably maybe asked in your examination. Okay, my dear friends. So hopefully you all are doing well and downloaded your admit card, and start your preparation well. Take the test series and make more and more practice now, because you haven't much more time now. And also uh, join the test series and take more and more test series now. So this will be beneficial to all of you. Okay, my dear friends. So let's start IC engine. Okay. So some basic point I will discuss there. Just wait. See, first of all, what's happened, my dear friends? So you can see first, suppose this is our any piston cylinder arrangement. Okay, and let there two port. One is inlet port, and other is what? You can say this is what exhaust port. Okay, and in initial case what's happened, there is a piston cylinder. You can say there is what a piston cylinder, and it comes down. Due to comes down, there is a suction. Okay, what in this state it comes down, so it is called what? Suction. In suction what's happened, suppose there is air fuel mixture, AFM. So AFM will enters inside your piston or cylinder inside your system. When piston comes down, the pressure, their pressure becomes less than that of atmospheric pressure. So what's happened after that? AFM will enters in our piston. Okay. So now we can say here in this figure we can say that here completely suction has takes place. So there is a this is your cylinder piston, and in this case inlet valve will be open. Okay, so in this what you can see here, all is filled here, all is filled by the fuel. Okay, so air fuel mixture is there, that all are is air fuel mixture. Okay, so now what's happened, now what you have to do, you have to compress this one. Okay, what you have to do, you have to compress. So what you will do after that, this one is our piston cylinder arrangement. Now you have starting the compression. That means you start the compress. That means suppose this is our TDC, top dead center. This is our IDC, or you can say sorry, bottom dead center, BDC. Top dead center and what? Bottom dead center, we can say. Okay, so what's happened, whenever compression will take place, both inlet valve and exhaust both will close, both will be closed, both are closed, and it's going to compress. Okay, so we can say from there what you can say, my dear friends, we can say that as you move the towards the TDC, as you move the towards the TDC, in this case both inlet and exhaust port will be closed. So what's happened in this case? Compression. This is compression. So what's happened when it's going to compress, my dear friends? When it's going to compress, so what's happened actually? Volume is going to decrease. Okay, pressure and temperature is going to increase. What's happened here? We can say during compression, During compression, what will happen? Temperature will increase. Okay, during compression, what will happen? Temperature and pressure both will be what? Increase. Okay, now try to understand at the end of compression. Now what is going to happen at the end of compression? Okay, so we can understand this is your inlet fault, and yes, this is your exhaust port. And suppose here your spark plug, let's assume first we discuss about the auto cycle. So what's happened, there will be a spark plug. So let's assume this is your what? A spark plug. Okay, so at the end of compression there will be your piston. At the end of compression there will be piston. And you know, my dear friends, at the end of compression temperature will be very very high. At the end of compression temperature will be very very high. So what's happened, you know, here is petrol is there, fuel is there. So at the end of compression temperature is much more very very high. And the same time, at the same time, here a spark is going to ignite. A spark is going to ignite. Okay, and when a spark is starting there, so what's happened, there will be burning. When a sparking will be there, so fuel is there at higher temperature, so what will be happen, there will be burning. Okay, there will be burning. So there will be burning. Okay, so you know, my dear friends, as burning will occurs, temperature again increases. This temperature is due to compression, and this temperature is increased rapidly due to what? Rapidly due to the burning, due to the sparking. Okay, now you know now PV equal to what? MRT. Okay, my dear friends, now tell me one thing, just tell me one thing. Whenever burning will be there, it will take long time or it will take slightly less time or very very less time. Yes, you can say a very compressed is there. Whenever a spark will be there, burning will take place in a fraction of time, or we can say within a 0.0001 second. 0.001 second, you know, no, 1 upon 1000, that is a very small time. So in this case, what's happened, my dear friends, this piston looks like that it is in the statics condition, looks like that it is in the rest condition, looks like. Therefore, my dear friends, I used to say that auto engine is a constant volume heat addition. Why? Because when burning will take place, this piston will be approx in the rest condition, approx in the rest condition. So in this case, this volume is constant, this volume is constant. So we can say that auto cycle or a spark engine or SI engine is a constant volume heat addition. Are you getting this point? So my dear friends, tell me one thing, V is constant, so MR is also constant, so you can say P is directly proportional to T. And you know, my dear friends, in the burning, temperature will be very very high. Temperature will be very very high. If temperature will be very very high, that means pressure will be also very very high. That means pressure will be also very very high. So what's happened here, pressure will be also high. So pressure is a scalar quantity, you know. So it will exert from all the direction, and due to this, you know, this all r will be fixed, only piston is free to move. So piston will starting move, piston will start to move to downward direction. Are you getting this point? Due to this pressure. Okay, what you will do, my dear friends, what you used to do, tell me. You used to connect this one to your you know, crankcase. Okay, when it comes down, then crankcase start rotate. That means when piston comes down, crankcase your start rotating, it will start what? Rotating. And you know, my dear friends, by the various arrangement, what you do, you are going to connect your wheel, you know, wheel, WHWL, this is what? Wheel. Okay, so what's happened, my dear friends, power will generate there, this is called power stroke. When power is generated there, so what's happened, it will move, it will start rotating crankcase. And by the various arrangement, I am connecting crankcase with my wheel. As crankcase is rotating, wheel is also going to rotating. And in this case, what's happened, your vehicle is going to move, your vehicle is going to move. So this is called what? Power stroke. And this is going to take place at a constant volume in case of auto cycle. Okay, now what's happened, my dear friends, it comes down. So what's happened, it comes down completely. So it will comes there, it will comes there. Okay, it will comes there. So now completely expansion is takes place, or we can say expansion started. What is this? Expansion started, and completely expansion takes place here. In this case, completely expansion takes place, this will be clearance volume. Okay, So no, at the end of expansion, and power stroke is also, expansion is a power stroke. Only one stroke is there in which you are going to get the power. So this is called what? Power stroke or expansion, whatever you can say. So my dear friends, so what's happened at the end? At the end of expansion, outlet valve is going to open. At the end of expansion, outlet valve is going to what? Open. And of once once outlet valve is open, there is a very high temperature and pressure, burning gases. So once this exhaust valve will open, most of the gases is going to escape. Most of the burning gases is going to escape. Therefore, or na, so at the end of expansion, so it is here, that means piston is fixed there, and this volume is constant. Therefore, my dear friends, used to say that Otto cycle is a constant volume heat rejection. Therefore, you used to say Otto cycle is a constant volume heat rejection. Why? Whenever inlet valve, outlet valve will open, since there is high pressure and temperature, all the burning gas will going to out or escape. Therefore, you used to say it is a constant volume heat rejection process. Okay, my dear friends. And after that, what you have to do? And the last stage, that is called what? Exhaust stage. Again you move this. 90% of gas is going to escape. How much? 90%. 90 to 95% burning gas will escape from there. Only 10% will be there. How much? Only 10% or 5%. So this will be going out at the exhaust stroke. At the what? Exhaust. Whenever piston again move up, so it is called what? Exhaust stroke. This is called what? Exhaust stroke. And remaining gas is going to out. Okay, and one more thing, my dear friends, I want to tell you. In mole vehicles, we have seen there is a use of what? Flywheel. And now flywheel going to use to store the energy. So what's happened in this case? Whenever you are getting the more energy, so it will be stored by the flywheel. And remaining stroke, only one expansion, only one power stroke is there. Remaining three strokes you have need a power. So what's I have to do? Actually, I connect the flywheel, and flywheel going to store the power during the expansion stroke, and same power or same energy is going to release or going to give in the remaining stroke, that is for suction, compression, and exhaust stroke. All this power is going to consume or going to use. Okay, my dear friends. So this is the what? Basic principle of what? Auto cycle. Okay. Same thing will be in the what? Diesel cycle. But diesel cycle mein what's happen, my dear friends? This is called a spark ignition engine, or you can say what? This is called auto cycle, or you can say SI engine. Okay, auto cycle, SI engine, whatever you can say. Now, if you talk about what? Diesel cycle. What? Next is what? A diesel cycle. So what is going to happen in the diesel cycle, my dear friends? Try to understand. In diesel cycle, is what's happen? Suction will be same. Okay, suction will be same. And in case of compression, suction will be same as the SI engine. Okay, air will come. Just one point you have to come in suction. If you talk about the suction, so in SI engine, air fuel mixture, AFM will come, air fuel mixture. But in compression, that means diesel engine or CI engine, in CI engine, or you can say diesel engine, only air will come. What? Only air will come. But in but in SI engine, air fuel mixture both will come. But in diesel cycle, only air will come. Okay. So my dear friends, this points what is going to happening in this. Suppose this one. So in this, let's this is our your just assume compression. Okay, compression is going to take place. Initially what's happened, my dear friends? Initially what's happened? Initially this is your suction. You can say in suction what is going to happen? Air is coming. Air will come only, not air fuel mixture. Okay, and this is compression. Compression is going to take place. Then what's happened? Temperature will rise. Why? It is going to compress. So temperature will rise. And what's happened at the end of compression? Suppose this is the end of compression. When it will reach the top dead center, So what is going to happen, my dear friends? There is a fuel injector. What this is? This is what fuel injector. And in this case, what's happened? I have compressed so much. I have compressed so much that the temperature reaches to the ignition temperature of the fuel. Temperature reaches to ignition temperature of the fuel. And whenever fuel will injected by this fuel injector, fuel will comes inside. So what's happened? Since their temperature is very high, it will ignite itself. It will ignite. Therefore, it is called CI engine. Sorry, self ignition engine. Or therefore, you can so diesel engine is, it is going to ignite itself. Okay. So this thing, when it comes again, it will be burning. But in this case, what's happened? As burning will takes place, the piston will start to move. Okay, piston will start to move. Burning is again happen. Slightly pressure increases. Again it's move. Slightly pressure increases. Just try to understand. Just try to understand. So this is your cylinder, piston. You, as pressure increases, it's move slightly. Again pressure increases, again move slightly. So therefore it is called what? Constant pressure heat addition. What? Because in this case, whenever you are going to add the heat, pressure remains constant. Pressure remains what? Constant. Therefore it is said that diesel cycle is a constant pressure heat addition. And also diesel cycle is also known as constant volume heat rejection, because heat rejection will be same at the end of expansion. This is the end of expansion. And at the end of expansion, outlet valve will close, will open. Outlet valve will what? Open. And when outlet valve will be open, so whatever burning gas is there, it will be going out. And during this, this will remains constant. Okay, therefore dear friends, I used to say that diesel cycle is a constant volume heat rejection. Okay, auto cycle is also constant volume heat rejection, but diesel cycle is constant pressure heat addition. So we can say, in this constant pressure, whenever just try to understand, pressure will increase slightly, it will move. Again slightly pressure increase, again it will move. Again slightly pressure increase, again it will move. Therefore it is called constant pressure heat addition. Okay. So this is one brief discussion about auto cycle. This is our auto cycle. So you can see here, this is our what PV diagram, my dear friends. Okay, here at a constant volume, heat is going to add. This is what HA means heat addition at a constant volume. After that, it is going to expansion. Okay, and this is what heat rejection. Okay, so you have to know, this is what from there to there, this is what this one is V1. Okay, V1 you can say Vs plus Vc. Vc is what? This is called compression, clearance volume. Vc is what? Vc is what? Clearance volume. Okay, so here this one we can say V2 equal to V3. You can say 2 and 3 constant volume is there, so we can say just, so V2 equal to V3 equal to what? Vc. So this is called what? Clearance volume. Okay, and this one these are different process that I have discussed here. And this will be what? Constant volume heat rejection. And it is going to compression, it is what? Your expansion. Okay, so my dear friends, if you ask what will be the efficiency, so efficiency will be 1 minus 1 upon r ke power gamma minus 1. Okay, what is r? R is called compression ratio. Compression ratio. And r is given by what? V1 upon V2. What? V1 upon V2. What will be compression ratio? V1 upon V2. Or you can say what is V1, or you can write like that, R equal to V1. So you can write V2 plus Vs upon V2. So you can write 1 plus Vs upon V2. What is Vs? Vs is swept volume. What is this? This is what? A swept volume. What is Vs? Vs is what? Swept volume. Okay, so v you can write this one 1 plus 1 upon c, and c is called our clearance ratio. C will be what? This is called what? Clearance ratio. So sometimes you have to find the question in question clearance ratio will be given, and they will ask to calculate the efficiency. So you can use this equation. Okay, so R equal to what? 1 plus 1 upon C. C is clearance ratio, or you can write Vs upon Vc, or directly you can write this one equal to V1 upon what? V2. Okay, so this thing you have to keep in mind. Okay, my dear friends, and this will be what? Efficiency of the auto cycle. We can write efficiency of what? Auto cycle. Now take this one is what? A diesel cycle, or this is also known as what? Constant pressure. Constant pressure heat addition. Okay, why? Because in this process heat is going to add at a constant pressure. So one more thing, my dear friends, one thing you have to put keep in mind, this one, V2, this is called, cutoff point. Cutoff, the point at which heat is going to add. At point 2 fuel is going to add. Okay, at point 3 fuel is going to complete it. That means whatever fuel is going to take place of burning, fuel is going to supply. So point 2 to 3, in this case only fuel is going to supply. So this is called what? Cutoff point. 3, V3 is called cutoff point. Why? Because at the point 3 the fuel is going to cut. After that it is going to expansion. From 2 to 3 you can see. So try to understand this one. How will be there this diagram? How will be? So try to understand this one. So this is your point 2. Okay, this is your point 2, and this is your, let's assume, fuel injector is there, and this is your point 2. So fuel is going to spray here, and it will spray till, or it will going to add till this piston will move to the point 3. After that fuel will be not supplied. Okay, after that fuel will be no supply. So 2 to 3 is called what? Fuel supply is going to take place from 2 to 3. After that fuel supply is going to off, or going to cut off. Therefore point 3 is known as cutoff point. Okay, and after that you can understand what will be. Just need a full board, so I am disabling my video. Okay, so you can write here, if you know what will be efficiency of diesel cycle, my dear friends. So you can write this one very easily. Efficiency of diesel cycle, this will be what? 1 minus 1 upon r ke power, okay, gamma minus 1. Inside the bracket you can write rho ke power gamma minus 1 upon gamma into rho minus 1. Now question is that, sir, what is rho? So rho is called cutoff ratio. Cutoff ratio, and it is always given by V3 upon V2. V3 upon V2. So point 3 to 2 cutoff is going to take place. So it is called cutoff ratio, and it is given by V3 upon V2. Hopefully this point is cleared. Okay, hopefully this point is what? Cleared. So this is called what? Cutoff ratio. And what is R? This is called compression ratio, and it is what? V1 upon V2. One more thing I want to tell you, my dear friends, whenever you talk about this ratio, cutoff ratio, or compression ratio, or expansion ratio, so my dear friends, you have to keep in mind this value will be always more than 1. So cutoff ratio, so V3 upon V2 will be more than 1. Are you getting this point? This will be always more than 1. If you talk about RE, so it is called expansion ratio. Okay, so expansion ratio will also be more than 1. So don't be confused about the what expansion. Whenever you talk about the ratio, so be careful that this value will be more than 1. So do not you haven't need to confuse about this one. Okay, so in question I will see the role of expansion ratio also. Okay, my dear friends, so this was all about the discussion. Now we can okay, once some in question sometimes you have to discuss about the mean effective pressure. Mean effective pressure. Okay, so this is also playing very important role. So this is called what? P mean, PM. Okay, so what is this, my dear friends? What is a mean effective pressure? Try to understand this one. Actually it is not a actual, it is a imaginary pressure. What? It is imaginary pressure which gives the same work done as by the actual cycle for the same change in the volume. That means for the same shaped volume, okay, first you have to understand it is imaginary pressure which will give the same work done as by the actual cycle for the same change in swept volume. That means it is imaginary. If you have actual cycle, so work done will be given by this pressure will be same. You know, my dear friends. What is you have to understand what is W net. So this will be PM into Vs. What is Vs? Swept volume. And W net is what? PM into Vs. So sometimes in question you have to calculate PM. So directly you can write PM equal to W net upon what? Vs. This is what now this one, okay. Or you can write directly you can write PM. What is swept volume? Swept volume is V1 minus V2. In this diagram you can see what is swept volume. Swept volume is from this point to this point now. So this one whole is V1, okay, and this V2, this is VC or V2, whatever you can say. I have attended V2 equal to VC is the same thing, okay. So my dear friends, you have to understand this point, okay. So work done will be what? Pressure into Vs, swept volume, and swept volume can be written as V1 minus V2 or VC. So this thing you can find here, and by this we can solve the question, okay. So now take this question, how we can solve this question, my dear friends. How we can solve this question? Question is that the figure below shows a thermodynamic cycle undergo by a certain system. Find the mean effective pressure in Newton per meter square. This figure is given in this question. So how we can solve this question? So try to understand. First, you have to calculate the area, my dear friends. Can you calculate area? Once you calculate the area, thing will be easier. Okay. So what will be area in this case? This area, how you can calculate? This is triangle. Hopefully you can calculate very easily. So what will be area? So we can know half. Okay, difference is this one. So you can write 3. And what is their difference? 0.02. If you solve, then I think you will get 0.03, 0.03 kilo Newton meter. Okay, kilo Newton meter. So what you have to calculate? You have to calculate, and no, my dear friends, area under the PV diagram gives what? Work transfer. Na, this thing you have to know. Area under the PV diagram gives what? Work transfer. So you can write this one is work. So you know what will be work equal to PM multiplied by Vs. Okay. So in this question you have to calculate PM. So what will be work upon Vs? Okay. So what is work? 0.0 sorry, sorry, 0.03 kilonewton upon what is swept volume. Swept volume will be 0.03 minus 0.01. Okay. So if you solve, then you will get PM, and you will get the value of PM is 1.5 kilopascal. Okay. So this will be the answer. PM 1.5 kilopascal. Clear? So now take some another question. Take this question. A engine working on air standard auto cycle has a cylindrical diameter of 10 cm and a stroke length of 15 centimeter. The ratio of a specific heat for air is 1.4. If the clearance volume is 196.33 cubic centimeter, that means cc, and the heat supplied per kg of air per cycle is 1800 kilojoule per kg, the work output per cycle per kg of air is, okay. So how you can solve this question, my dear friends? How we can solve? So in this question you can see here some key point. What is the key point? Try to understand how we can solve this question. This is also important. So or such kinds of question. An engine working on air standard cycle. So what you have to do? First to draw the air standard cycle. Air standard auto cycle is there. So first draw the air standard auto cycle. Okay. So this point is 1. Just assume this one is 2, 1, 3 and 4. Okay, so an engine working on air cycle has a cylindrical diameter. That means cylindrical diameter is given. So D is given how much? D is given 10 centimeter. And a stroke length, that means a stroke length L is given how much? 15 centimeter is given. Okay, the ratio of a specific heat of air, that means in this question gamma is given how much? 1.4. If the clearance volume is, that means in this question Vc equal to V2. What is this? One is clearance volume, no, my dear friends. This one is what? Clearance volume. Vc equal to V2. So this one is given in this question, and the value is how much? 196.3 cubic centimeter Cc. Okay, and heat supplied per kg of air per cycle is, so in this question qs is also given, heat supplied. So and this value is 1800 kilojoule per kg. The work output of the cycle per kg of air is. Okay, so in this question, what you have to calculate? This is your PV diagram, work output. One thing I want to tell you, suppose if it would be a square, then directly you can find the area and you will get. But it is not a square, so it will be very difficult to you to calculate this area. It will be very difficult to you to calculate this area. You can't calculate, okay? So my dear friends, I have to use some different concept, okay? So I have to calculate work, okay? So suppose anyhow, if I get the efficiency, then yes, I can calculate W upon QS. In this question, QS is given. If I calculate efficiency, I can calculate work done very easily. So reverse, sometimes you have to think. Reversely you can think, okay? So first we have calculate the efficiency. Once efficiency is calculated, QS is given, you can calculate W or work very easily. So now first you have to calculate efficiency, and you know how efficiency you can calculate. 1 minus 1 upon r. Okay, write down here, you can write efficiency equal to 1 minus 1 upon r whole ke power gamma minus 1. Okay, so since it's auto cycle, so this will be what our equation. But in this question you can find r is not given. What is r? This is compression ratio. Compression ratio is not given, my dear friends. So how, what is compression ratio? This will be v1 upon v2. So in this question you can calculate, this one is not given. So your first target is to calculate what? Compression ratio. Once compression ratio is calculated, you can calculate all the things. Okay, my dear friends. So how you can calculate? So in this question, first calculate V1. Yes, you can calculate V1. What will be the value of V1, my dear friends? This will be pi by 4 d square into L. Okay. So V1 we can calculate pi by 4 d square into L. If you put the value, then you will get the value of Vs. I think it will be double one. Just wait. 77.5 cm square, na? Yes, cmq, because volume is there. So cmq. So you have calculated the v1. Okay, you have calculated what? V1. And in this question, sorry, this is what sorry, this is not a v1 here. This is vs, swept volume. Okay, sorry, this is swept volume from this point to this point, vs. So what is the value of vs? So vs will be how much? Vs will be, this is my mistake, pi by 4 d square into L. Let's take another question, right? Vs equal to pi by 4 d square into L. If you solve, then we will get the value of Vs 1177.5 cmq. Once we calculated the Vs, so you know what will be R, or compression ratio. You can write V1 upon what? V2, this one, or you can say Vc. Once you calculate, you can do all the things. What is the value of V1? So you can write Vc plus Vs upon V2. You can write Vc also, because V2 equal to Vc is there. So in this question, Vc is given how much? 196.3 minus 1177.5 upon how much? 196.3. If you solve, then you will get the value 6.99, or you can say approximate 7. Are you getting this point? Approximate 7. So you get the compression ratio. Once you get the compression ratio, you can calculate efficiency of auto cycle easily. So what will be this value? 1 minus 1 upon r ke power gamma minus 1, and 1 minus 1 upon r, you can write approximate 7, 1.4 minus 1. So if you solve, then you will get this value will be, if you solve, then this value will be 54%. How much? 54%, or you can say 0.54. 0.54. Once you have calculated the efficiency, so you know what will efficiency w upon qs. So 0.54 equal to 0.54 w upon what is the value of qs, 1800 is there. So my dear friends, you can calculate w, and this value will comes out to be 973.08 kilojoule per kg. Hopefully you have get the question. So my dear friends, sometimes you have to think the reverse. Okay, first thing what you have to calculate it, then think how you can calculate, how many different parameter need to calculate this particular value, and you can proceed after that. Okay, so this one, now take this question. So what is this question? Try to understand this one. The stroke and bore, that means stroke length and bore of a four stroke spark ignition. Spark means what? SI engine. Okay. Spark ignition engine are 250 mm and 200 mm respectively. The clearance volume is 0.001 meter cube. If the specific heat ratio, that means gamma, is 1.4, the air standard cycle efficiency of the engine is option A 46.40%, option B 56.10%, option C 58.20%, and option D is 62.80%. So my dear friends, how we can solve this question? Okay, so how you can solve this question? So try to understand this one first. See, the air standard cycle efficiency of the engine, that means what you have to calculate, actually you have to calculate efficiency. So you know what is efficiency of auto cycle, you can write 1 minus 1 upon r ke power gamma minus 1. Okay, so in this question you can calculate that gamma is given how much, gamma is given 1.4, but in this question compression ratio is not given. Again, compression ratio is what? Not given. So you have to first calculate the compression ratio. This question is, you can say, very similar to the previous question. So you know what is r, v1 upon what, v2. Okay, so in this question a stroke and bore is given, so you can calculate it vs pi by 4 d square into l. So what will be this value? Pi by 4. What is diameter? So you can put and diameter is how much? A stroke and bore. So if you solve, then vs directly I am writing the value. So directly the value will be a vs, this will be 7.85 multiplied by 10 to the power minus 3 meter cube. Okay, once we get the vs, okay, so what will be v1, my dear friends? You can write vs plus vc. Okay, vs plus vc. In this question vc is given how much? 0.001 meter cube. So what will be vn? 7.85 multiplied by 10 to the power minus 3 plus of 0.001. If you solve, then you will get the value of v1, and it will be 8.85 multiplied by 10 to the power minus 3 meter cube. Okay, once you get the v1, okay, so what is compression ratio? R, v1 upon what, v2 or vc, whatever you can say. So this value will comes out to be 8.85 multiplied by 10 to the minus 3 upon 0.001. And if you solve, okay, so you will get the value of r directly. What will be compression ratio? This will be 8.85. Okay, this will be 8.85. Once we get this one, you can calculate efficiency 1 minus 1 upon 8.85 whole power 1.4 minus 1. And if you solve, then you will get the efficiency, and efficiency will be 58.2%. So 58.20%. So you can say c is the correct answer. Okay, so c will be what? Correct answer. Okay, so now take this question. Garam pani thora, garam. अच्छा ठीक. Okay, so now take this question. For an engine operating on air standard auto cycle, the clearance volume is 10% of the swept volume. The specific heat ratio of air is 1.4. The air standard efficiency cycle is okay. So this question, how you can calculate? Just wait. Just wait. So how you can solve this question, my dear friends? Sorry. So in this question, for an engine operating on air standard Otto cycle, the clearance volume is 10% of the swept volume. The specific heat ratio is given and the air standard efficiency. I think you can solve this question very easily, my dear friends. No need to solve if such kinds of question is going to ask. So you can solve this one. So first, you have to calculate what efficiency of the Otto cycle. So you can know 1 upon 1 power 1 upon r ke power gamma minus 1. In this question, gamma is given. Just what we have to calculate, we have to calculate r. That means we have to calculate what? You have to calculate what? Compression ratio. And you know what is the compression ratio, my dear friends? What is the compression ratio? V1 upon what? Vc. Okay. So you can calculate compression ratio very easily, okay, my dear friends. Why? Because in this you can write now like that. What will be V1? Vc plus Vs upon Vc. So you can write 1 plus Vs upon Vc, okay. But in this question, one thing is given, 1 plus Vs is 100. So you can write Vs upon zero point 0.1 of Vc. If you solve, uh, or you can write Vs, because Vc equal to how much? 0.1% of Vs. So directly you can write from this one, and if you solve, you will get the value of 11. And once you get the value of r, that means 11, we can solve this very easily. Efficiency will be how much? Efficiency of Otto cycle, 1 minus 1 upon 11 whole power 1.4 minus 1. So you solve, and you can get the answer, and this answer will be 61.67. How much? 61.67%. Okay, so this will be the answer of this question. So D is the right answer. So now let's take some question on the diesel cycle. So this all our discussion on the what? Auto cycle. Now take some question on the diesel cycle. Okay, so you can take this question. What is this? uh, in a compression ignition engine, that means in a ci engine, the inlet air pressure is 1 bar, and the pressure at the end of isentropic compression is 32.42 bar. The expansion ratio is 8. Assuming ratio of specific heat, that means gamma, as 1.4, the air standard efficiency inside the bracket in percentage e dot dot dot. That means such kinds of question you can expect in what? NAT, a numerical answer type question. So how you can solve this question? So it is given in a compression engine, that means CI engine, okay, ignition engine. The inlet air pressure is 1 bar. Inlet air pressure, that means we can say in this question P1 is given. So first draw the parts diesel cycle. First draw the diesel cycle. So how we can draw the diesel cycle? This one is your P. This one is what? P. So we can draw this one very easily. So this one is your cycle. You can write 1, 2, 3 and 4. Okay, this one is our what cycle. Okay, so in this question, P1 is given how much 1 bar is given, P2, and that means pressure P2 is also given, and this value is 32.42 bar is there. Okay, the expansion ratio, that means in this question expansion ratio is also given. So expansion ratio, so what is expansion ratio, my dear friends? I have told you, this is value V3 upon, okay, expansion ratio na. So you can write expansion ratio V4 upon V3, or you can write V1 upon V3. Okay, so you have to remember, because I have told you now, whenever you talk about the these kinds of ratio, so it will be always process ratio, basically this is known as, and all the process ratio always will be more than one. Okay, so this point we have to keep in mind. So it is what expansion, so you know expansion is going to take place from 3 to 4. Expansion is going to take place from 3 to 4, therefore it is called what expansion ratio. But you know v4 equal to v1, so you can write this one. Okay, and this value is given how much, 8. So what you have to calculate, my dear friends, you have to calculate efficiency. If you know what will be efficiency of diesel cycle or ci engine, whatever you can say, compression ignition. So if you have remember, so you can write 1 upon r, this is you have to remember. Okay, inside bracket rho ke power gamma minus 1 upon gamma rho minus 1. Okay, so this is our equation, this is our equation to find the efficiency of what ci engine. Okay, so my dear friends, in this question what you have to calculate it first. Okay, so in this question compression ratio is not given, so first you have to calculate the compression ratio, and after that compression ratio, and after that you have to calculate rho. This is called what, this is called what, cut off ratio, cut off ratio, this is called what, cutoff ratio. So these two things we have to calculate it. Once these two things we have calculated, you get the answer. So your target is to calculate it first gamma, sorry, r, because gamma is given, 1.4 gamma is given. So calculate r and calculate rho, that is cutoff ratio, and then you can proceed to solve this question. Okay, so you know process 1 to 2, if you talk about process 1 to 2, 1 to 2, just wait. Process 1 से 2, what is process 1 से 2? So you know this is what, can you write this one, p1 compression is v1 के power gamma equal to how much, p2 v2 के power gamma. Okay, so what will be v1 upon v2 whole power gamma. So you can write what, p2 upon p1. Okay, so from there I think you can calculate it v1 upon v2. Okay, so what you can calculate it here, v1 upon v2 you can calculate what is the so you can write v1 upon v2 equal to p2 upon p1 upon के power what, 1 upon gamma, and this is nothing but v1 upon v2, this is also known as r. If you solve, then you will get the value of r, approximate compression ratio, this is 12. Once you get the compression ratio, now your target to calculate what, cutoff ratio. Okay, so how you can calculate cutoff ratio? So you know what is rho, rho is how, v3 upon v2. So my dear friends, can you see, can you write it like that? Okay, so if you know v3 upon what, v2 is there. So in this question, if you solve v3 upon what, v2, so directly you can write here v4 is also. So from there you know v4, so by this relation if you solve, then you will get the value of rho. You can directly write like that, v3 upon v2, so v1 upon 8 multiplied by 12 upon v1. So directly you can find this value, and this value will comes out to be how much, 1.5. Okay, so all the things you have calculate, rho is how much, 1.5. So efficiency now you can calculate it very easily. So what will be efficiency? If you solve by putting all this value, you will get the efficiency is 59.6%. Okay, what will be efficiency? This will be 59.6%. So such kinds of question you can also expect. Now take this question, and this question will be last of our discussion of this class. So what is this question? Okay, a diesel engine has a compression ratio of 17. That means diesel engine is there and compression ratio is directly given 17. And cutoff takes place at 10% of the stroke. Assuming ratio of specific heat gamma, that means gamma is given how much? Gamma is given how much? 1.4. The air standard efficiency in percentage is, that means what you have to calculate? You have to calculate efficiency of diesel cycle will be what? Okay, so first write down the efficiency of diesel cycle formula. So you can write 1 upon 1 के power compression ratio के power gamma minus 1 into cutoff ratio power gamma upon 1 into gamma cutoff ratio minus 1. So this one is your what equation to calculate the efficiency. Okay, so my dear friends, tell me how you can calculate. And if you draw the diagram of what CI engine, so it will be something like that. Okay, this one will be your equation. And in okay, so this is objective question, but suppose if such kinds of question is going to what ask in your exam, so just wait, this is our mistake here. Okay, so this one is equation, we can see here. So this point is 1, and this one is how much? This one 2, 3 and 4. Okay, so in this question r is given. Anyhow you calculate the row, that means you will get the answer. But in this question one information is given. What this information is given cutoff. So what is cutoff? Cutoff is v3 minus v2. V3 minus v2 cutoff takes place at 10% of the stroke volume. So you can write 10%, that means 10 upon 100. What is stroke volume, my dear friends? V1 minus v2. So this is the stroke volume. From this point to this point, from this point to this point is what? Vs. So this is our what? Stroke volume. Okay, so in by using this concept you can find all the things in the very easily. So can you write? I am taking another slide, just wait. So can you write like that, this thing? So cutoff ratio is 0.1 of what? Stroke volume. So can you write like that? V3 minus V2 equal to zero point 0.1 of V1 minus V2. Yes, you can write. So now you can write like that. V3 upon V2 minus 1 into V2 equal to zero point 0.1 V1 upon V2 minus 1 into V2. Yes, you can write. So what will happen? This V2 will be what? Cancel out. So what you can write? V3 upon V2 minus 1 equal to zero point 0.1. Okay, v1 upon v2 minus 1. So why I have done? Because v1 upon v2 I have known. Okay, so v3 upon v2 I have to calculate. So you can write 1. Okay, you can write 1. Direct this will come this one, so it will be positive 0 0.1. What is v1 upon v2? 17 is given here. Okay, v1 upon v2 how much? 17 or 16? V1 upon v2 is how much? 17. So you can write 17 minus 1. So if you solve for this one, so this is what v3 upon v2 equal to our row, and you will get the value of 2.6. Okay, once we get the value of compression, you know what cutoff ratio, what is row, this is our cutoff ratio. So my dear friends, you can calculate it, the efficiency of diesel cycle very easily. 1 minus 1 upon r power gamma minus 1 into what? Rho के power gamma minus 1 upon gamma into rho minus 1. So this thing you have calculated very easily. So what? 1 upon r is how much? 17 power 1.4 minus 1 inside bracket what is rho, so 2.6 power 1.4 minus 1 upon 1.4 2.6 minus 1. And if you solve, dear friends, then you will get the value, and this will comes out to be 59%. How much comes out to be? 59.6%. Okay, 59.6%. Okay, so this was all about our discussion about the IC engine. Okay, okay, one more thing I want to tell you, sometimes question may be asked from the dual cycle also, but very few question is going to ask from the dual cycle. But if you interested, then you can remember their formulas of the you know what, this one, that means a dual cycle. But generally notes going to ask in the exam, because it is a very tedious formula, but you can't say for safe you can remember, but all these things you have to remember. And also sometimes what's happening in objective question, you have to compare the all the, in the different condition of IC, in the different condition of this one, auto cycle and diesel cycle and dual cycle, this one. So this thing you have to also keep in mind. Okay, so all these things can comes in the exam, so be prepared for that. Just one thing that you have to do at your home on yourself, what first remember the the different, or a comparison between the auto, diesel and dual cycle. Okay, for short, I can say, just you have to remember, if in the question it is given for same compression ratio, is given, so in this case you have to remember always efficiency of the auto cycle will be more. In other all the remaining cases, the efficiency of the diesel cycle will be more, and efficiency of dual cycle will be in between of diesel cycle and auto cycle. This thing you have to point. Whenever you see the question in question, there is given same compression ratio, so don't be confused. Tick, in this case the efficiency of the auto cycle always will be more. Okay, and in other thing is there, not this point is not given in the question, that means same compression ratio. So in such case we can go through the option having diesel cycle more efficient. Okay, so my dear friends, that all was about the discussion of IC engine. Hopefully you guys have got and prepared well for coming exam. Okay, now for more practice, we can purchase our test series. That means the test series of Gate Forum. Okay, for getting more marks and getting more confident in exam, we can purchase our test series. That means Gate Forum test series. And yes, for more detailed discussions for this, we can join our eGate live class also, that is going to start soon. So you can join the eGate live class also for your getting more concept, or getting the concept clear whatever doubt you have. And one more course that we have launched this year, this is what refresher course. In refresher course, what's happened, sometimes the students have not time to attend the live class. So what's happened, so for those students you are providing the refresher course. In refresher course, all the concept is going to discuss in the very detailed manner, and proper very detailed manner. All the concept is going to discuss in the refresher course, so you can purchase this one. And also with the refresher course, I will Gate Forum will provide you all the access of all the questions in the coming last 10 years or 11 years, whatever all the question you can get in the solution in the video format or audio format. So no need to worry, you will get lot of benefited from this course. So my dear friends, this all was about the total discussion. So let's think you guys have get all the things, and good luck for your coming exam. Thank you. Thank you to attending this session. So now let's finish the session. Okay. Bye.